Hello everybody, I'm here to tell you today how xDNA inheritance works and how it can help you find common ancestors with your DNA matches. Now if you look at these graphics, you'll see that this is the pattern in which xDNA is inherited from your ancestors. So since the X chromosome is passed from mother to child, you'll see that a son will only get the X from his mother, since males are usually XY, and a female DNA kit will have two X chromosomes, one from the mother and one from the father. So the X is compiled of segments that come from all of your ancestors who follow this line of inheritance. The pattern is female to female or female to female. A man doesn't pass his X to a man unless there's a chromosomal abnormality, which is incredibly rare and probably won't show up in your DNA kit. So that being said, let's go take a look at DNA Painter and Gedmatch and see how this can help you find your DNA matches. So the first thing you want to do is set up a new DNA Painter profile if you haven't already. So this is a blank DNA Painter profile. And you pop over to Gedmatch and run your autosomal one-to-many with the kit that you want to use. Now just start with autosomal and then switch to xDNA after that so that you get both autosomal and X matches. So once you find a kit that matches both your autosomal and your X, you open up an X one-to-one and a regular one-to-one compare. Copy the kit number that you want to compare to into both of the windows that you just opened, and also your own kit. You can just run these side by side because we're going to need them for the next step. This is why I like to have lots of extra tabs open, because you're going to need to do a lot of copying and pasting in Gedmatch. So there's that, and we click submit on both windows and you'll see some results, and leave both those windows open. So next you want to Command or Control All, Command or Control C. So you've copied all this to your clipboard, paint a new match in DNA Painter, paste it in, and then you copy and paste the name and kit of who you're working with into the name of your DNA match. It's always good to keep the kit number there too. Make a new group, call it X match or whatever you want to call it. We don't know what side it's on yet, so we say not sure. If this was a male kit, you'd know it was your maternal kit, but this is a female kit, so we're not sure. You'll see it didn't save the X chromosome, so that means we have to paste that separately, but you can do that by clicking Add More Segments and copy and paste from your X one-to-one the same way, and it will be in the same DNA match instead of making a separate one for it. Click Save, and there you see it. So this has two segments down there. So since we're working with xDNA, we can predict your relationship to your most recent common ancestor, or MRCA, with this handy tool in Gedmatch called the Relationship Calculator. So you'll need the name and kit of you and your match. You just paste those in the places that are provided for it, and since you left your windows open with your one-to-one, you're going to need the information from that too. So it'll ask you your total centimorgans for your autosomal and your largest segment for your autosomal, your total for your X, and your largest for your X. It'll also ask you about your age difference with the match, whether you're around the same age or one or two generations farther from your MRCA. And once you've entered all of that in, you can run it and you'll see what it looks like. The relationship projector can be a little confusing at first, but bear with me here. So there's a little information here on how it works and what information it's pulling, and its measure of accuracy, and how many generations it thinks you are from your most recent common ancestor, and your predicted cousin relationship based on the X. This only works if you have an X match, by the way. You can't do this with only autosomal. So this looks pretty crazy, but what you have to bear in mind is that there's a space for you, which is the first one there, and a space for the match, that you're attempting to match with, and all these little lines that go to potential relationships to your MRCA. Now, some of them seem like dead ends, but if you look at the information in the box, it tells you the predicted amount of material that you have on your X from that ancestor, if any. And there'll be groups labeled with green that say MRCA group, and those are the places where it thinks that you're going to have MRCAs. So the other nice thing about DNA Painter is that you can copy and paste from the site that you tested with too, usually, unless you're testing with Ancestry, which doesn't have a Chromosome browser. Go into Chromosome browser, copy all again, Command or Control A, Command and Control C, and paste it into DNA Painter the same way. If you're working with an X match, you might have to lower the centimorgan threshold in order to get it to show up, but you save it the same way you would any other way. And sometimes DNA Painter will predict what group it thinks you should add people to. You'll see there's a little bit of a X match right there. Here's the tree of the match, and so you can see all the names here. We're looking for any that are familiar and tracing where she might have gotten her xDNA from. And here is the kit that we're testing against and where you are looking for potential MRCAs. Now, if we open up some of these branches, you'll see that we have Abigail Day and Elisha Day, and we found our MRCA. So we can go back to DNA Painter and edit the match. So we'll go and edit on DNA Painter and make a new group and name it after the MRCA that we just found. Since this is an X match and it's following the pattern of X inheritance, we know that it came from Elisha Day Sr., so we'll put his name in first. And you can make a note for yourself in the match too to remind yourself. So that's how you use DNA Painter to stay organized and figure out where your xDNA segments come from. I hope this helped out, and I hope it helps you to find all of your MRCAs and solve all of your hard DNA puzzles. And thanks for watching.